Here in this video, we are solving two questions that appeared in NEET 2023 physics paper in the chapter electric potential and capacitance. See the first problem. The equivalent capacity of the system as shown in the figure is how much, right? So it's a very simple question. The first thing that you can understand is this capacitor and this capacitor are in parallel. How do you say they are in parallel is their plate 1 and plate 1 are connected here. Their plate 2s are also connected here. This kind of a connection is called parallel connection. We know capacitors in parallel is having an equivalent capacitance of C1 and C2. This is in contrast to resistors. Resistors in parallel is 1 by R equal to 1 by R1 plus 1 by R2. You have to be careful with that. Then this is 3 and 3, so this becomes 6 microfarad. We can draw an equivalent circuit as there is this 3 microfarad, that is this one I am talking. Instead of these two now, I can write only one. Sorry, that is, instead of that 2, I can write only one, that is 6 microfarad. So it's very clear that these two capacitors are in series. It's like an end-to-end connection. You know, capacitors in series means 1 by C series equal to 1 by C1 plus 1 by C2, that is exactly in reverse to the resistors. So capacity C equal to C1 C2 by C1 plus C2. C1 is 3, C2 is 6. So 3 into 6 by 3 plus 6 is 9. This is 3, 6 by 3 is 2. So the answer is 2 microfarad. That's the answer for that first problem, a very small question. Let's have a look at the second question. An electric dipole is placed as shown. First of all, what do you mean by a dipole is a charge of equal magnitude but opposite signs, minus q and plus q, separated by a certain distance, 3 and 3. That's the distance between the two dipoles. What is the electric potential at a point? Of course, this is 10 power 2, not 10 power 2 volts at a point P. See, on this point P, due to this positive charge, there will be some potential. First thing is, potential is a scalar. Be careful about it. It's not a vector to assign a direction. But potential due to a positive charge is positive. Potential due to a negative charge is negative. Just know of that. Due to this charge also, there will be another potential V2. So the total potential at the point P is sum of the two potentials. Just add them. They don't have any directions. Due to the first one, 1 by 4 pi epsilon naught q by this distance. How much is this distance is? If you notice carefully, this total distance is 5. This distance is 3. So this distance becomes 5 minus 3, that is 2 centimeters. So this is 2 centimeters. I have to convert that into meters into 10 power minus 2 volts. Plus potential due to the other one, this one due to 1 by 4 pi epsilon naught. This is a minus charge, so I have to take it like minus q. Then that distance between them is, from here to here is 3. From here to here is 5. Altogether that is 8 centimeters. Of course, centimeters has to be again converted into meters. So q by 4 pi epsilon naught is common. 10 power minus 2 is also common. What is remaining is 1 by 2 minus 1 by 8. So this is q by 4 pi epsilon naught. 10 power plus 2 minus 2 in the numerator. For 2 and 8, LCM is 8. This is 4 minus 1. That is 3q by 8. 1 by 4 pi epsilon naught is being written like k in the problem. So k into, of course, 10 power 2 is there, it is in common. So your answer has to be 3q by 8k. That's the answer for the problem. That's how option B is the answer. That's how we solve this question. Thank you for watching.